Good morning, everybody. Welcome to Earth Science, or good afternoon, I guess, if you're in a later class. Um, what I got for you here is figuring out cloud base altitude. Now, this is like the next step when it comes to relative humidity and dew point problems. I'm actually not going to have everybody do this. This is for folks that really nailed all that relative humidity stuff, that are doing great in class, which I really appreciate. So this is like, don't overstress this assignment. Give this like a, hey, this is a Friday try. Check this out for a minute. See if you can figure a couple of them out and some of the patterns. It's neat. It definitely applies to meteorology and how clouds form and all of that. Um, but I don't think we're gonna have time for everybody to do it. So I don't mean to like punish you with more work because you've done your work, but like let this be a low stress one is what I'm saying. And doesn't it look like a low stress one? Look at that graph right there. It's actually reasonably easy to use. This used to be in the reference tables back when I took New York State Air Science. This was in the reference tables. They've taken it out since. Um, But what it shows us is how high in the sky will the bases of clouds form. So, what I want you to picture, and I don't know how much you pay attention to clouds and weather and all that in your life, is like one of these like summer nice blue sky days with puffy clouds. And oftentimes the bottoms of those clouds are perfectly flat. So, that's just like the easiest scenario to picture this. At what altitude in the sky does the bottom of that cloud form? So as air rises, and we'll be figuring out soon that when air rises, it expands and cools, and it eventually cools to the dew point, and that's when clouds form. I'm going to make you say that like 1,000 times. But as this air rises, what altitude it's going to be cooling and cooling and cooling and cooling and cooling? How high does it have to get? How cool does it have to get before it hits the dew point and condenses into water vapor, which is what clouds are? Clouds are liquid water, which is sometimes a surprise to folks. Now, today it's looking like we got kind of like generic stratus like clouds, sheet like clouds, living exactly downwind of a lake, right off of Lake Ontario, as we all do. That's such a giant source of moisture, so much warm water there that we just kind of get these clouds, inundated upon us. It's a very cloudy place to live, which you'll find out if you move anywhere else besides like Seattle. If you go anywhere else in the country, you're going to find out it's a lot sunnier. So, like when I lived in Minnesota, in Minneapolis, like there'd be days where the clouds were just unbelievably high. It almost felt bizarre how high in the sky they got. You just never see that here, and it's because it's more humid here because there's a giant lake right there. Like I said, so how do we figure this out? Some of it is going to have to be going back to your reference tables and using. See if I left it queued up here. Using these guys, relative humidity and dew points, which hopefully we're at a point where we're pretty comfortable with. Okay, so that's like nothing new here. Dry bulb, wet temp, it's wet bulb. So it'd be 20, and you put in 1 because it went down to 19, and you get your dew point, your relative humidity. Now, how high in the sky is the cloud? That's where it's going to get a little trickier. What this shows us, there's a lot of lines on here, but your job, if you figure this out, and again, don't panic about it. If you figure this out, is to distinguish between. I love it when the thing won't slide. There we go. These dotted lines right here that say dew point, and then these solid lines that say dry bulb temperature. And then there's also a graph in the background, right? Like this 2.5 to 2.5 line goes across, and there's these up and down lines. But the ones we really need to focus on, and you only need to focus on one of them, is the line that says dew point is a dotted line, and the line that says dry bulb temperature. So what you would do for that is, I suppose I got to solve this dew point to get you there. So if it is, was it 20 and 1? That means the dew point's going to be 19. I'll make you do the relative humidity. So we're going to take 20 and 19, and we're basically just going to see where they meet. I'll move my head out of the way. This little diagram here kind of does it for you. Follow the solid line down until it meets the dotted line. Now these two are close, so it's going to be pretty low. But what I want to do, this stupid thing, I think it's easiest as you learn this to like use a pen Your call. Let's go back up and just make sure we're doing it right. That the dry bulb temperature are these solid lines, right? So what we're saying, what this chart tells us is that if it's 20 degrees outside, if we were to go up in a hot air balloon, the temperature will be decreasing at this rate. This is called the lapse rate. Now it's colder as you go up. Like you know that because you've seen snow-capped mountains, right? It's cold higher in altitude. And it's because when air rises, it cools. It has less pressure on it. It spreads out, and that cools it down. So that is the lapse rate at 20 degrees. Somewhere on that line, clouds will form. Now, if the dew point is 19, all we got to do is say, where does the dew point line intersect with that? I'm going to use a different color because I think it's going to be easier. The dew point line, remember, is the dotted line right here. All right. Now, yes, they don't list odd numbers, but there's 18, there's 20. If there was a dotted line, it would just kind of go in between those two and go up, 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 right? But we don't really have to go that high because this is the spot where they intersect right here. So in other words, in a day with those conditions, the clouds are going to form. And I know my lines are perfectly straight here, but again, we're not doing any panicking today. That's how high in the sky the clouds would form. I believe this is in kilometers. Yep. So it'd be about 0.15 to 0.2 kilometers. We'll go 0.15. That's how high in the sky the clouds form. Now, that's not very high, but one of the ideas here, once you see this all, is that the closer together, and hopefully this is an idea you have, if you really have been cranking the way it seems you have, this idea of if the dry bulb and the dew points are close together, that means it's humid. In fact, if they're the same, it's 100% humid. If you've ever been in a fog, that's 100% relative humidity. It's basically a cloud at ground level. And the further apart they are, the more dry it is. What this lesson would add on top of that then, I'm going to zoom out just a touch. What this lesson would add on top of that is, okay, if they're close together, that means you don't have to go very high in the sky before those meet, so the clouds are going to be very low, like they tend to be in central New York because it's a humid place. Whereas if you're in a dry place and the two values are very far apart, you're going to have to go way higher in the sky before you have clouds form. Okay. So let's, give that a go. I didn't check these to make sure every single one works. This is the one, I do this like, I've done this maybe 2 or 3 times. I don't do this every year. I know I had one worksheet that was screwed up, but I think this is a good one. What are the current conditions outside? I did look that up. So I'm going to be extra mean here, though, too, and make you convert. So time and date, you know what that is. What I'm getting for a dew point right now in Pulaski as of 7:45 this morning is 14 F. You're going to have to convert that to Celsius, though, using the reference table. And what else do you need? The temp, which is 17. And no wonder those clouds are not very high in the sky this morning. Convert those to Celsius, solve for relative humidity, and get yourself a cloud base. Let's make sure none of these are too hard. Mm-hmm. If you can't figure out rates, don't panic about that. Some folks, like if you've done that in math, it's basically a slope. How quickly is it going down? Rise over run. If that's like, don't, that'd be unrelated anyway. Don't worry about it. Same question, just with dew points. Which changes faster? That'd be the steeper slope. So look at the 2 lines, which is steeper. I'd say, I don't know, this is kind of abstract, having humid air blow into town. Or you could even just say living downwind of a giant lake. If there's fog in the air, that's basically, like I said, that's the cloud at ground level. And when air rises, it cools. If it sinks, what's it do? Oh, yeah, so that'd be cool. What happens then when air is sinking? If we really get into the meat of meteorology, when air is sinking, what would that do, like humidity-wise? That'd be a clever one to figure out. See if you can do it. Again, none of this is critical. If you get to a question, you're like, man, I don't know. If you tried a couple of them, you got the basic concept of higher versus lower. You're doing a great job. I really do appreciate the hard work. And we can talk over future weeks about what to do as you guys are really nailing stuff. Like what do you want to do? I don't want to just like let you off the hook and say, yeah, you're done, go away. But I don't want to necessarily always do just like, here's extra work. What can we do to like find that middle ground to do something that's like, okay, here's one more neat idea, and okay, here's some pointless work, right? I don't think this is pointless. I think it's cool, but I don't know. If you have any strong feelings on that, write me. I'll stop rambling. We'll see you guys Monday. Start something fresh. Once you're done with this, if you're done with everything else, go ahead and log off. We'll catch you.